Enterprises are racing to build AI infrastructure. We are talking billions of dollars in GPU clusters, massive data pipelines, and bare metal systems that need to be up and running yesterday. But here is a challenge. These AI factories are some of the most complex infrastructure deployments we have ever seen. Smart NICs, multiple GPUs per server, network, and one misconfiguration can stall a multi-million dollar project for weeks. So, how do you get AI infrastructure right the first time at scale without the pain? That is exactly what we are going to talk about in this episode of Agentic Enterprise with Rob Hirschfeld, CEO and co-founder of RackN. Rob, it's great to have you back on the show.
It's a pleasure as always.
Let's start with a term that is getting a lot of attention, AI factory. What exactly is an AI factory and why is everyone talking about it?
AI factory is used in a couple of different ways. In generally, what we see it meaning as this idea that you want to have a standard footprint to do AI inference and training, probably more training even than inference. But the idea is that you're creating a known quantity that you can reproduce that generates AI workloads and automation. And that's fundamentally sort of the unit that we're thinking of. So instead of AI cluster or AI workstation or AI workload, the going term seems to be AI factory.
So how does it encapsulate all AI related operations like the factory floor? You've got supply chain, raw materials coming in, the production line, and then the output. Is that how we should think about it?
You're right. There's a challenge that we have because we are so close to the bare metal and how people look at buying servers and things like that. So when people think about an AI factory, they very much mean the physical plant that creates AI, which is where the factory analogy comes in. It is a little bit confusing because it's not like an assembly line and you're making widgets and things like that. But it is the equipment that you buy, the location that you have that produces AI results. So if you're a model builder, then that AI factory is racks of training gear. If you're an inference system, then that AI factory is racks of inference engine pieces. And it's very much in all the OEMs that we talk about, and the AI builders are all thinking in this terms of I'm building an AI factory. Now, it could be thousands of machines, it often is, but that's the idea on what they're building. What we have seen, though, is that a lot of times that ends up being one cluster at a time. So somebody might be building a AI training cluster and think of that as an AI factory when they've got 10 clusters. So they might still think of those clusters as 10 factories, AI factories, where they're building an output out of the system. It's good as a frame of reference because it does talk about the mechanical, physical plant that you need to accomplish AI versus running a model or doing inference or having an API. Those are the differences that we see when we're talking to somebody who actually wants to be running an AI system as opposed to using an AI system.
Is AI factory a well-known term or it is something that is being coined right now? Sometimes we create terms to solve specific problems or build better understanding like DevSecOps, DevOps, SREs. Can you talk about the nuance behind this term?
The idea of coining a term is an interesting thing. And we've had times when somebody, like when we first started doing Edge, there was a lot of misplaced people spending a lot of time defining what edge meant. And cloud is the same type of thing. There was pushback in the idea of calling it cloud initially. So it's not something that RackN is trying to term. This is something, AI factories are a request that we get over and over again. So when we talk to hardware OEMs, when we talk to partners, when we talk to customers building, they are using the term AI factory. So it is an emergent term for AI hardware and infrastructure, and what that build looks like, which I think is important because we're different than saying an AI cluster. That's typically not as clear as somebody saying, oh, I'm actually buying the gear. I'm actually running the infrastructure.
When you look at organizations building AI factories, NVIDIA, Tesla, companies ingesting massive amounts of data in real time, these teams are rushing to get infrastructure up and running. And we are talking bare metal here, not virtualized systems. So walk us through the pressure these teams are facing and what are the resources available. And of course, what's the play here for Raken?
Yeah, there's two things you said that I really want to highlight. One of them is talking about data, and we all know that data is absolutely critical for AI training, and the performance of the systems to ingest data is actually part of the reason why these are AI factories, because it's not as simple as taking a traditional data storage system or a data lake and hooking it up to a switch and then attaching servers to it. The AI factories that we're talking about are highly tuned systems that are all put together to accomplish a specific task. So we're building AI factories to suit, or the industry is building them to suit what RackN is doing, and comes up to the second part of your question, which is the urgency, is our automation is being used to drive the delivery of the infrastructure in ready-to-go state of these AI factories. So just because you have an architect, what we usually call at RackN a layer 0 design. So an architect designs the networking topology and the smart NICs and the machines and the GPUs, and all of that layout is done. Even though that's done, and the teams above that, the AI ops and the platform teams, they know what they're going to lay down and they know what models they're going to run and they know how they're going to do it. What we're finding is these are incredibly complex systems. They're very expensive. The need to get them in market and used is incredibly urgent, right? Our customers who are building AI factories, they take delivery of racks. They don't even know in advance what's going to show up when. They just get them as fast as they can possibly get them. They rack them. They need them running yesterday. They're incredibly expensive systems. We've talked about this a bit already, but it's not just the cost of the systems, right? $250,000 per server, hundreds of millions of dollars per rack, billions of dollars per rack. It's the fact that the opportunity cost of not having these clusters running is significant. And so what we're finding is the automation necessary, and this is where RackN's specialty comes in, this layer 1 automation to qualify the system, inventory it, detect issues, patch and update it, set the networking topology correctly, get all of the bits and pieces of security, the operating systems installed so that it can join the AI clusters. All of that work, that has to be done. It's incredibly detailed work. There's a lot of expertise in that network topology, in having multiple NICs and how everything gets wired together and how smart NICs are configured. What we're finding is the precision needed to reliably automate this gear is something that Digital Rebar was purpose-built for, but our customers, don't have the tooling, they don't have the expertise to just walk into a data center and have these racks up and running. The ones who've done it manually, just to get their prototypes going, then find that manual effort doesn't scale. And you have to learn how to make all this stuff work.
You folks deal with bare metal, and bare metal is always being challenging. New hardware versions, software updates, things can go tricky fast. So walk us through how complex these AI systems are compared to regular data center deployments. What makes them different, and what are the additional complexities that is where RackN enters the picture to help organizations tackle those complexities?
It's a little bit of a paradox because at some point these are just servers. And yet, if you put smart NICs and GPUs in a system, especially when you're putting multiple smart NICs and multiple GPUs, those are also functionally servers. And what we've seen and then there's also, if you're using a neocloud, and a lot of our customers are, the neoclouds are delivering the systems, and then our customer takes over control of the systems. And so what you have is somebody's delivering you a server that's going through their provisioning process. What we've seen is that sometimes the neoclouds are going to keep control or keep a boot provision component running in the system. All they need to do is deliver the system to you. They're not worried about any other configurations, right? Our team spent over a week troubleshooting the fact that each NIC on the system was a server, and those servers were grabbing DHCP and responding to IP addresses and interacting with the overall provisioning network and the topology of the system independently of each other. It's something that we walked in, diagnosed very quickly. Somebody said, no, it can't possibly be the fact that these smart NICs are still engaged or still responding. And we went down a different diagnostic path, and we had to come back and re-troubleshoot to figure out exactly what was going on, because people insisted that they knew all of the components. But when you have this many pieces and parts in a server, what you have is a lot more potential conflicts. You have a lot more potential places for configuration. You have a lot more places for conflicting configuration and systems that somebody thinks, oh, this isn't important, so I ignored it earlier down in your pipeline of delivery. And then when the system got turned on, those disabled or ignored components start interacting, and that beginning interaction then causes problems. This is true for out-of-band management and being able to reassign credentials. This is true for how PXE boots are handled. Secure PXE booting is very specific. These challenges are also enterprise challenges. The difference here is that you are much more likely to hit these concerns because you have so much more going on in the server, and you're in a big rush to do it. And that's one of the challenges, is that we're talking to customers, and they want these servers on yesterday, and they're trying to meet very strict deadlines. They're paying a lot of money to get systems. There's a tremendous amount of pressure, and that, human-wise, the urgency to make things happen, trying to get things going, that creates its own process problems. There's a Marine Corps saying, which is slow is smooth, smooth is fast. And what we see over and over again is the pressure, the deadlines, the urgency to get these systems up and running actually undermines teams' ability to troubleshoot, take stepwise, put in systems and processes that then speed them up. Because it's not just, can you deliver the system today? Every customer we've seen doing AI workloads, frankly, everybody we've seen doing virtualization workloads, they benefit from being able to do apply, reset, patch, and return systems in, sort of like a race car pit crew. You can run your systems as fast as you want to, but they have to come in for the pit. They have to get updated. If your pit doesn't do a good job updating, patching, getting the tires rotated, then you're going to have times where servers just, a whole cluster goes out because a server isn't patched and updated, and you haven't practiced those routines. You haven't gotten an established, repeatable process to do it. We've watched customers really resist the need to get those types of processes built. The ones that resist take months to get things going. The ones that lean in and make it happen, they're the ones that actually win in the end, because they've done the work ahead of time to have a repeatable process.
When you work with organizations, have you seen any self-inflicted wounds? What are some mistakes teams are making that you're like, these are so easy to avoid, and they are bringing past practices that don't apply anymore, or they build new wrong practices that should not be there in the first place? The point is, what are some of the mistakes that they are making they should not make?
I hope people take a lesson more broadly as they're doing AI work in general. Is right. They're finding that you can recreate the whole system from the sources over and over and over again. This ICP, infrastructure as code. This is the same principle, right? That you don't want to build everything and then hope you never have to change it. The goal is to have a repeatable way to recreate the whole system and the whole process. And spending the time to do that and iterate through those things, that translates into velocity in the end. It's one of those challenges. The other thing that we found that's worth mentioning is, we have really deep, bespoke knowledge about how bare metal infrastructure works. And with that knowledge is something that we've coded into Digital Rebar, but it's also something that we can show up for a customer and get things going, get them over hurdles, move them past challenging in configuration scenarios that might have otherwise taken weeks to unravel. Our team, because of our unique experience, can look past that and move straight to this root cause. It's just an aspect of us being the world experts in bare metal at this point. One of the ones we see over and over again is that the teams forget that there are knowledge layers in the organization and in their silos. Well, one of the problems that we see happen is that the platform team, so the people who are sort of running the model, trying to run Kubernetes, do AI ops, those teams make an assumption because they're using the models that they're going to be able to run and set up the infrastructure. And we see this problem. This isn't just an AI problem. We see this in enterprise quite a bit with Kubernetes running on bare metal for AI. A lot of virtualization pilots and AI pilots are stalled when the team that's trying to run the AI ops team or the virtualization admin teams, they don't have the bare metal expertise, but they brute force their way and they end up doing a whole bunch of manual, and they're learning bare metal at the same time they're trying to get their pilot running. And they're doing it because they want to just make the pilot work and be successful. But we've seen a lot of derailed pilots where they're taking months and months to get started or get the pilot complete so they can actually demonstrate the platform on top of it. And that's really frustrating because it means that their management confidence in their ability to execute is off. A lot of companies are trying to get off VMware, and those projects have taken a lot longer than they want to because people don't have the expertise to do, these alternate system setups anymore. And you have to bring in the teams that are responsible for running your physical infrastructure, or you have to find people like RackN who can actually come in and help and advise on how to do those, or bring in proven processes so you don't have to reinvent those processes. It's very hard to shortcut what those things are. And it's really sad for us. We have some customers that trust us very deeply. They still fall in the trap of saying, "Oh, I want to let my OpenShift team take a swing at this and try and figure out how to do it." And it's like, well, you're going to be using the ops team and Digital Rebar anyway. Why don't you just let us help you at the beginning? And they still wall off that team and try to help them be successful as an isolated thing. And this isn't just one customer. I've watched this pattern repeat over and over and over again. And so it's this problem of, organizations are siloed, operations teams are separate from platform teams. They don't talk very well together. And, that lack of communication, that lack of sort of helping each other succeed, thinking about the long term, frankly, it slows projects down. We've seen it result in a lot of missed delivery objectives. We've seen it result in a lot of VMware renewals. We've watched it result in a lot of AI studies and applications that are stalled. And when people look at running their own AI infrastructure, and management thinks they can't do it, it's because of problems like that. It's completely untrue. We have very successful companies that are running AI at scale and delivering systems very quickly. And they're the ones that have the strongest process discipline.
If you were advising an enterprise that is about to deploy AI infrastructure, what could they do upfront to streamline the process in addition to working with Raken, of course?
The number one thing you can do is to set aside systems if you can. And some of these systems are so expensive, you can't actually set them aside. But is to take the time to actually walk through what the process is, understand what your automation targets are and how all of those pieces are going to fit together, and do it as a team. It's going to feel slow. It's going to feel like you're getting a lot of people involved. You're going to have to study how these systems fit together, and you're going to feel like you're learning, and you're spending a lot more time studying your systems and understanding things. But if you don't do that, you're not going to be able to replicate success. And I think that's the advice I would give somebody is that make sure that as you're going through this process, you understand how you got to a successful outcome. If you don't have a way to replicate what your successful outcome is and then tear it back down and start over and go through those steps again, and that can be hard if you're in a rush. If you can't replicate success, then you actually don't know why you were successful. You just got lucky. And I think that is the thing that I would tell people to think about, as they look at any IT work, but especially these AI workloads, is that you need to make sure you understand how you got to the place you want to get and be so confident in it that you can flush everything and start over. And if you're an executive and you want to test this theory, what you want to do is ask your people, all right, you got it working, reset it back to zero and show me the whole process from nothing all the way through again. And if your team turns, starts looking very scared and nervous and doesn't want to do that, then they don't actually know how they got to the point of success. They're giving you a demo, and the demo might be fantastic, but without understanding how they did all the work to prep that, then you actually don't have a repeatable project. You've gotten lucky for AI in the moment, and at the pace AI is moving, luck is just not enough.
Let's talk specifically about how Raken is helping teams get this right. What is your approach to tackling this complexity? Things are evolving fast. MCP was launched last year. New versions are coming out. Agentic Enterprise Foundation is also there. New models keep coming out, new services. So how is Raken helping teams get their AI factory ready and running?
Yeah, we're not just stamping AI all over the product and calling it good. And we're not trying to pretend that a whole bunch of embedded AI is going to help anybody win in this model. I actually think that doing that would slow down the type of work that we're doing. What RackN does is we provide out of the box bare metal automation workflows. They're battle tested, they're time proven, they operate at scale. We've spent the last 10 years, banging through what it takes to make all this stuff work, and we built very concrete expertise in handling all of these systems, right? We had a customer show up and say, hey, by the way, we're buying these new servers and they're all ARM. Instead of, Intel or AMD, they're all ARM servers. And our systems had already supported ARM, and so we were able to roll that in, and it was a non-issue from the customer's perspective. But that type of expertise and knowledge and having all of our proven workflows work in an ARM environment, that is something that had to be done with deliberation and care and tested over a long period of time. And so when we work with customers here, what we're bringing is tremendous amounts of proven scale workflows where we have handled the quirks, where we know how to migrate between one version of Redfish and another version of Redfish, or mix and match OEM versions of controls and Redfish versions of controls. That blending of all these components, of being able to deal with SmartNICs in an elegant way and integrate them into the delivery of how a system works, deal with the networking topology and have very advanced image deployment capabilities that respect the number of disks and drives that are being loaded into these things. Every one of those components, all of those edge conditions, those have to be handled in a correct routine way. And that's really what we've built up, is standardized workflow that is API driven, that performs at scale, and frankly, out of the box, manages all of the equipment that's getting thrown at us. Because in a lot of cases, our customers, like I said earlier, don't even know what gear is going to show up. If the Dell server shows up before Supermicro, then great. If that shows up before Quanta, then whatever's racked, that rack, you get it, you inventory it, and you go. You don't have time to say, wait, I'm not ready for the Dell gear yet. Put that one on ice for a couple of weeks while we deal with something else. Right? Nobody has time to figure this stuff out on the fly. And that's fundamentally what we're bringing, is the fact that we've already done that work. We've already established the processes, and as new gear, new things get thrown at us, Digital Rebar is already ready to handle the variations that occur naturally in the environment without having custom code, without people having to figure it out on the fly.
This year is all about AI and agentic AI. What's one thing you feel enterprises need to understand about AI infrastructure that they are still missing? People get overhyped, some are scared. What do you want them to know?
This is the other part of the AI strategy that was in your question, and I should have answered more clearly. We see agentic AI as absolutely critical to enterprises. And what we see happening is enterprises having their agent systems. No, people don't want a RackN agentic management system. What they want is they want RackN, and this is exactly what we're doing, to take the time to build an MCP or a prompt dictionary so that AI knows how to use digital rebar effectively, so that you can issue high-level commands into your agent, and the agent will take the correct action in digital rebar and get a reliable result, that deterministic output rather than your stochastic parrot of pattern matching. And so what we expect to see is enterprises are going to increasingly invest in their own agentic systems. They're going to rely on one of the frontier models. They're going to build agent systems, and they're going to need to manage that, because enterprises are going to live or die on the quality of their agent responses and the guardrails that they put together for it. RackN's job is not to build an agentic system. There are already enterprises that are building them or buying them to use. Our job is to make sure that those agents have a way to interact with data center infrastructure in a reliable, repeatable way, and make that as smooth as possible, and continue to build our team's expertise in helping you troubleshoot issues that arise from agents talking to systems, setting up, right? There's a whole new diagnostic skill coming, which is, and my CTO and I were having this exact experience of having Claude using digital rebar in a way that no human would do, but was perfectly natural for a machine, and causing issues and having troubleshooting as a consequence. We have to be ready, and RackN is ready. I think your listeners have this challenge. They know they're going to have agents. They're going to need to control those agents, and then they have to be able to diagnose and troubleshoot the problems of the agents, steer them into the right outcomes, provide guardrails for them, and then figure out what happened when the agents take actions that, while logical, are not correct. And unwinding that, understanding that, those are the skills that RackN is building into how our systems operate, so that we are the proven choice for making our enterprises, digital workers, as effective as possible.
Rob, thank you so much for joining me and sharing these insights on AI factory infrastructure, bare metal complexity, and how critical it is to get repeatability right from day one. And as usual, I look forward to our next conversation. Thank you.
I appreciate the time. Thank you, Swap.
And for those watching, if you are facing similar challenges with AI infrastructure deployment, make sure to check out RackN and its solutions. And don't forget to subscribe to TFIR, like this video, and share it with your teams. Thanks for watching.